Hi folks, we're going to take a look at 13A from part A of the Unit 3 assignment. So they give us this model for population growth of bacteria, and they want us to determine the maximum number of bacteria and when it's reached. Okay, so here we're just going to start by taking the derivative, of course. All right, so we'll do this carefully here. So 10 to the 4 is just a constant. So in taking the derivative of this first part, I can just leave that out. So it's going to be 10 to the 4 times the derivative of that function there, which of course I'm going to have to use the product rule for. So derivative of t is 1 times the second function, so e to the negative 0.2t, okay, plus the first function t times the derivative of that one there. So this is like e to the u. Derivative of e to the u is just e to the u, so e to the negative 0.2t times the derivative of u. So derivative of negative 0.2t is just negative 0.2, okay, because the derivative of t is 1. So negative 0.2. Okay, and plus the derivative of 100 is just 0. Okay, so now since we want to determine a maximum, we're going to look for the critical points here. So we're going to make the derivative equal to 0, and let's solve this equation. So first thing I'm going to do is look for a common factor, and I see that there's a common factor of e to the negative 0.2t. So here I already have this this factor in front of 10 to the 4. Here I've got e to the negative 0.2t, and let's see what we have left. So here we're just left with 1 when we factor that out, and here we're just left with negative 0.2t, so minus 0.2t. And so since 10 to the 4 is just a constant and e to the negative 0.2t can never be equal to 0, the only thing that'll make this expression equal to 0 is if 1 minus 0.2t is equal to 0. So 0.2t equals 1, and t equals 1 over 0.2. But 0.2 is like 2 over 10 and 1, or 1 over 5, so t is equal to 5. Excuse me. So now we have to show that this indeed relates to maximum value. So I'm just going to create a number line here. So this is p prime, and now we just have to test the sign. Now again, 10 to the 4 is always positive, e to the negative 0.2t is always positive, so we only have to look at this part of the derivative, okay? So if I put, say, t equals 1, I have 1 minus 0.2, so that's going to be a positive number. And if I pick, say, t equals 10, 0.2 times 10 is 2, and 1 minus 2 is negative, so that's negative. So we're indeed going from increasing to decreasing, so this is a max. Okay, so now we just have to determine the actual answer to the question. So when is the max reached? So here, max is reached at 5. Actually, I just realized I do not remember what the units were. So the units are, t is time in days. Okay, sorry about that. So at 5 days. Okay, and what is the maximum? And the maximum is equal to, so now we'll just calculate that. So it's 10 to the 4 times 5. So I'm just inputting 5 into my original equation. So 5 times e to the negative 0.2 times 5 plus 100. Okay, so let's calculate that here. So what do we have? We have 10 exponent 4. Now I know that that's 10,000, but just to make sure I don't make a mistake, I'm just going to put exactly what I've got here. Okay, times 5 times e to the negative 0.2 times 5. Okay, and then plus 100, and we have 18,494 bacteria, approximately. All right. So just to recap here, we just did exactly what we always do to find a maximum. We take our function, we take the derivative, find the critical points. Here there was only one critical point. We tested it and saw that this turned out to be a maximum, which is what we were looking for. So that was then able to give us our answer. Okay, that's it for this one.